Alright, in this video, I want to talk about 3 examples using the SOCS to describe the distributions. Right here, I just state 3 different situations about the distributions. So let's talk about these examples one by one. Right, so since I made this data is not very big, right? Actually, we don't need the jump. We can calculate or just draw the histogram by hand, right? So here, let's draw the histogram first, right? So that you can describe the shape of this distribution, right? So when we look at the data, it actually starts, the minimal is 0, the largest is 7, right? So let's draw from 0, 1, 2, 3, 4, 5, 6, and 7. All right, and then let's say we have 2. I just make a dot, represent there is a 2. All right, next one is 3. Right, next one is 1, 5, 4, 3, 4, 1, 2, 3, 7, 6, 2, 3, and 1, 0. All right, and then based on these dots, I can draw the histogram, right? Based on their heights. So this is for 1. This is for 0. This is for 1. This is for 2. For 3, 4, 5, 6, and 7, right? Okay, then draw an overall curve based on that. Kind of looks like this, right? So actually this distribution is approximately symmetric, right? And it is unimodal, right? Only one peak, so it will be unimodal, symmetric. And is there any potential outliers? Actually, no, right? So we say no potential outliers. All right, so actually we kind of finished the first thing to describe the distribution, which is the shape, right? Okay, next let's talk about, and also the outliers, right? So since we don't have any potential outliers, we don't need to identify the lower limit or upper limit to identify whether there is any outliers. So from the histogram, there's no potential outliers, right? So we're done with the shape and outlier. Next, we'll talk about the center, right? So we say if the distribution is symmetric, then what we use for the center? We use what? We use the mean to describe the center. Right? So now we need to calculate the mean. We use the x bar to represent the mean, right? So the formula will be sum of all observations divided by the total number of observations, right? So actually, what is that? It's just the sum of all these observations, all of these values. So it will be 2 plus 3 plus 1 plus 5 until the last one 0, right? Divide by the total number of observations. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? So actually your n is 15, right? So if you calculate this, you will have 46 divided by 15, which is 3.07. All right, so next we need to describe the spread, right? All right, to describe this spread, we say we need to pair. If you use the mean, then you need to use the standard deviation to describe the spread, right? So since it is symmetric, it doesn't matter you use the IQR or standard deviation, but since you use the mean for the center, then you need to use the standard deviation to describe the spread. All right, so standard deviation will have the formula of sum of y minus y bar squared divided by n minus 1. Right, so it will be what will be sum of for each observation minus the mean of the observations squared divided by the total number of observations minus 1. Right, so then what is that? So the top will be a long one, right? So for each observation, you need to minus the mean of this data and then square it, right? Okay, so for the first observation will be 2, right? So you have 2 minus the mean, which is 3.07 squared, right? So this is the first y minus y bar squared, right? So for this case, you can just make it consistent because we can just change this formula to this will be easier so that you don't get confused. It doesn't matter you use x or y to represent the observations. All right, okay, so we have the summation sign, right? So we need to plus every term. So next one, we have this 3 in the data, right? So you have 3 minus 3.07, which is the mean squared, and then next one will be 1 minus 3.07 squared, and then next one will be 5 minus 3.07 squared, and so on. All right, until the last one will be 0 minus 3.07 squared. All right, so this is the top, and the bottom will be n equals to 15, right? 15 minus 1. So if you calculate this whole term, you will get the standard deviation equals to 1.91. All right, okay, then then we need a conclusion or a sentence to describe the whole SOCS about this distribution, right? So we say, therefore, the distribution, so this sentence is very important, right? So we cannot just list it like this. We need a whole sentence about your conclusion, right? So we say the distribution appears to be unimodal, approximately symmetric, centered around the mean of 3.07. Since we don't have the unit, so let's say 3.07 units, and with a standard deviation of 1.91 units. no potential outliers. All right. Okay, so this is for the first case. If the distribution shows it is approximately symmetric, right, or just a symmetric, then we can use the mean for the center and standard deviation for the spread. All right, next one. Okay, so let me change another color. Let's say this color would be good. Okay. All right, next data. All right, so once we have the data, we still need to draw the histogram, right? So now for this data, the minimum is 1, the maximum is 8, right? So you have 1, 2, 3, 4, 5, 6, 7, 8. Hopefully. Okay, and then I have 1, 6, 3, 7, 2, 4, 3, 2, 2, 3, 3, 8. All right, and then we can draw the histogram based on their heights. So there is no 5, so there is a gap here. All right, now if you draw this overall shape, it will be what? It will not be symmetric. It is skewed to the right, right? So it is skewed to the right. All right, next part, we need to decide it is, again, unimodel. Right? Any potential outliers? Looks like there is a gap at 5, but it doesn't look like these 3s are outliers, but we don't know yet, right? So let's keep it until the end so that we can calculate their lower limit and upper limit, right? To decide whether the 6, 7, 8 are outliers or not. All right, okay, so we're done with the shape outlier at the end, and the next one will be C, which is the center. Right, okay, now this distribution is not symmetric. That means what? That means it is skewed distribution. If it is skewed distribution, we use median to describe the center. All right, so now we need to find the median. Now to find the median, the first step will be sort the data from the smallest to the biggest, right? So actually when you make this histogram, you have already ordered or sort them, right? From the smallest to the biggest. Right, so you have 1 of 1, you have 3 2s, right? You have 3 2s, and you have, I'm not sure whether this is a dot or not. 1, 2, 3, 4. So you have 4 3s. So this is not a dot. Right, so we have 1, 2, 3, 4, 4 3s, 1 4, 1 6, 1 7, 1 8. Right now we need to find the middle value, right? So let's count how many observations here. 1 2 3 4 5 6 7 8 9 10 11 12. So we have even number of observations, right? So if it is even number of observations, n equals to 12, that means we have 6 at the first half, 6 at the second half, right? So where is the middle value? The middle value will be these two, right? Okay, so your median will be what? Or median will be just the average of these two values. So it would be 3 plus 3 divided by 2, which is just 3. All right, so this is about the center. Then what about the spread? Right, we say we need to pair with median and IQR, right? So to describe the spread, we need to use IQR. To find the IQR, it is calculated from Q3 minus Q1, right? So actually we need to find what is Q1, what is Q3, right? Okay, so actually for this case, the median is the middle two values are 3 and 3, right? So now we need to divide this whole data set into 2 equal parts, right? So that means the first part will be 1, 2, 2, 2, 3, 3, right? The second part will be, second half will be 3, 3, 4, 6, 7, 8, right? Okay, and then Q1 will be the median of the first part, the first half. So will be what? Will be middle this two, right? So will be Q1 will be the average of these two numbers, so it will be just 2, right? Q3 will be the middle of this half, right? So will be Q3, which is the average of 4 plus 4 and 6, so will be 4 plus 6 divided by 2, which is 5, right? So that means you have IQR will equals to Q3, which is 5 minus Q1, which is 2, equals to 3. All right, so now we have the center, we have the spread. The only one left will be the potential outliers, right? So to identify whether there is any outliers, you need to do what? You need to do calculate the lower limit and the upper limit, right? So for the lower limit will be Q1 minus 1.5 times the IQR, right? So will be what? Will be Q1, which is 2, minus 1.5 times IQR, which is 3, right? So it will be 2 minus 4.5, which is negative 2.5. So this is the lower limit, right? Upper limit. So the upper limit will be Q3 plus 1.5 times IQR. All right, so it will be Q3, which is 5, plus 1.5 times IQR, which is 3, right? So it will be 5 plus 4.5, which is 9.5, right? So we say any value outside this range will be the outliers. So we have the maximum is 8. So 8 is still in this range. That means the 8 is not outlier. That means 6 and 7, of course, will not be the outlier too, right? So for this case, we say no outliers. All right, now we need a whole sentence or whole conclusion to describe this distribution, right? So we say this distribution is unimodal, skewed to the right, or right skewed, right? And with center of the median at, which is 3 units, right? And the IQR of, what is IQR? Is 3 units with no outliers. All right, so now you have the whole conclusion about, or description about this distribution. All right, so this is the second case that if your distribution is not symmetric, if your distribution is skewed to the right, right, then you need to use the median and the IQR instead of mean and standard deviation to describe the center and spread. All right, okay, so this is the case for even number of observations. Next example, I just add another observation, a large kind of an outlier, right? So now let's still draw the histogram. All right. Okay, so we have smallest from 1. Yeah, right. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, and then there is a far away is 101. Right, so we have 1, 6, 3, 7, 2, 4, 3, 2, 2, 3, 3, 8, and 101. Right, so if you draw the histogram, it will be the same with the last example. Right, and there is one far away from the distribution, right? So now if we still draw this distribution, will be some skew to the right again, right? And it's still unimodal, right? But there are potential outliers, right? So maybe this one is an extreme outlier. All right, and then since it is skewed to the right, right, so we still need to use the median to describe the center. Right, so now our data set is ordered like you have 1, 1, 3 2s, 4 3s, and you have 1 4, 1 6, 1 7, 1 8, and 1 101. All right, okay, now we have 1 2 3 4 5 6 7 8 9 10 11 12 13. So you have 13 observations. All right, that means you don't have the even number of observations, you have odd number of observations. All right, so now in this case, how you can find the median? We find the middle number, right? So since it is n equals to 13, that means there are 6 of them here, another 6 here, right, with the middle another one. So 6 plus 6 is 12, and plus the middle 3 will be 13 observations, right? So this 3 will be the middle value, which is the median, right? So that means your median equals to 3. All right, next one, we need to find the IQR to describe the spread, right, as a pair of median and IQR, right? So again, for IQR, you need to find Q3 and Q1, right? To find Q1 and Q3, you need to divide the whole data set into 2 equal halves. But what about how to deal with the middle one? Still remember? We need to include this middle value twice in both halves, right? So that means for the first half will be 1, 2, 2, 2, 3, 3, include the middle 3 as the first half, right? The second half will still include the middle value, will be 3, 3, 4, 6, 7, 8, 101. Right, include this middle value twice in both halves. All right, now for the first half, find the median. So what is the median? Will be this, right? The middle value. So this is your Q1. So Q1 equals to 2, right? So for this half, the middle value will be 6. Right, so you have Q3 equals to 6. So your IQR will equals to Q3, which is 6 minus Q1, which is 2, will equals to 4. All right, so actually from here you can see that even if we have an extreme outlier here, to describe the spread or the center, it will not be affected a lot because what? Because the median and the IQR are both resistant to outliers, right? They will not be affected a lot by the outliers, right? So the median will still be 3. The spread IQR just change a little bit, change from 3 to 4, right? Didn't change much. But if you use the mean, it will be changed a lot by this 101, right? Okay, so if the distribution is skewed, then you need to use the median and IQR to describe the center and the spread. Right, so next we need to identify or decide whether this extreme outlier is a true outlier or not, right? By calculate the lower limit and upper limit. Right, so the lower limit will be what? Will be still Q1 minus 1.5 times IQR, right? So it will be Q1, which is 2 minus 1.5 times IQR, which is 4. So it will be 2 minus 6, which is negative 4, right? So the upper level will be Q3 plus 1.5 times IQR. So Q3 will be 6 plus 1.5 times IQR. Will be the IQR here is 4. right? So it will be 6 plus 6, which is 12, right? So any value within this range will not be outliers. That means this 6, 7, 8 will not be outliers, but this 101 is outside this range. That means the observation of 101 is an outlier, right? Okay, now it's time for us to make a conclusion about this distribution. We say this distribution is unimodal, right? Skew to the right. And what? And with the center at, which is median at 3 units, right? And IQR at 4 units. There is also a extreme outlier at what? At 101 units. All right, so here I just make 3 examples based on 3 different conditions, right? So first, if if the distribution is symmetric, then you use the mean and calculate the mean and standard deviation for the center and spread. All right, and if the distribution is skewed, then you need to use the median and IQR for the center and spread. Right? If you have an even number of observations, then the median will be the average of the middle 2 values, right, for your sorted data. All right, and then when you find the Q1 and Q2, you need to divide these middle 2 values into 2 halves. All right, okay, to find and then find the Q1 and Q3. If it is skewed distribution, but you have odd number of observations, then you need to include this middle value into both these 2 halves to form these 2 equal parts. All right, and then you will have the Q1 and Q3 for the median of the both halves. Right, so you may ask me that whether I can use JUMP to provide this information, because it will be easier. You don't need to calculate like this, right? I need to say that the mean and median, I need to say the mean and standard deviation will be the same. But for the median and IQR for the Q1 and Q3, JUMP will show different results, because JUMP will use another method to find the Q1 and Q3. So especially in the exam, right? I will not ask you. I don't think I will ask you to use the JUMP. Right, so you need to calculate and type in your answer by hand and calculate these ones, or find the median and IQR by hand. Right, so you need to follow these steps, not by JUMP. Right, if you use JUMP, you may have different answers. All right, okay, and I think before you complete the computer labs 3, you better to watch this video and then make sure you understand it, and if you have any questions, just let me know. All right.